NASA releases eerie audio recording from black hole. Listen to it here. Did you know that in space, you can't hear a black hole scream, but evidently you can hear it sing? What is a black hole? How is it associated with sound? Is it audible to the human ear? How? These may be the questions that arise in your mind, and soon you will get your answers in this video, so stay tuned. Hello guys, and welcome back to TechVerse. Today, this informative video is based on some cosmic discoveries. Let's dive into the content. Trust me, after watching this video, you will undoubtedly find it informative. The sounds of the black hole released by NASA spooked internet users, and some even saw a skull in the visual image of the black hole at the center of the Perseus galaxy cluster. Astrophysicists working with NASA's orbiting Chandra X-ray Observatory detected a pattern of ripples in the X-ray glow of a giant cluster of galaxies in the constellation Perseus in the year 2003. They were pressure waves, or can be said sound waves, which were 30,000 light-years across and radiating outward through the thin, ultra-hot gas that suffuses galaxy clusters. A supermassive black hole caused these periodic explosions at the center of the cluster. This cluster's 250 million light-years ahead and consisted of thousands of galaxies. The sound waves are acoustically equivalent to a B-flat 57 octaves below middle C, a tone that the black hole has been grasping for the last 2 billion years, having a period of oscillation of 10 million years. Astronomers doubt that these decelerate the star formation, keeping the gas in the cluster too hot that the new stars cannot condense. These ripples were sonified by speeding up the signals to 57 or 58 octaves above their original pitch and increasing their frequency quadrillions of times so that they are audible to the human ear. As an outcome, the rest of us can now hear the interstellar sirens singing. With the help of these new cosmic headphones, the Perseus black hole makes eerie moans and rumbles, which reminds us of the clumping tones tracing an alien radio signal that Jodie Foster hears through headphones in the science fiction film Contact. Internet users were terrified by the black hole's eerie noises, and some claim to have seen a skull. There have been several Twitter users who have commented that it sounds like horror film music. Have you seen the visual images and heard the sound of the black hole? How do you feel after hearing these sounds? Let me know in the comments. This new sonification, the conversion of astronomical data into sound, is being released in conjunction with NASA's Black Hole Week 2022. This sonification is unique in several respects because it rejoins real sound waves detected in data from NASA's Chandra X-ray Observatory, but some could argue that there is no sound in space. Right. Well, the widespread belief that there is no sound in space stems from the fact that much of space is effectively a vacuum, with no medium for sound waves to flow through. A galaxy cluster, on the other hand, contains massive volumes of gas enveloping hundreds or even thousands of galaxies inside it, providing a medium for sound waves to flow through. Previously ascertained by astronomers, sound waves were extracted and made audible for the first time in this new sonification of Perseus. The sound is extracted in radial directions, that is from the center outwards. The signals were then integrated into the human hearing range by scaling them up by 57 and 58 octaves above their real pitch respectively. Another way to describe it is that way they are heard 144 and 288 quadrillion times higher than their original frequency. A quadrillion is defined as a number equal to 1 followed by 15 zeros. The radar sweep around the screen allows you to hear waves coming from various directions. Blue and purple in the visual image of this data represents X-ray data captured by Chandra. This new sonification does not use that data, but instead examines data from other telescopes that viewed M87's considerably larger sails in the same period. The visual image comprises 3 panels from top to bottom. X-rays from Chandra, optical light from NASA's Hubble Space Telescope, and radio waves from Chile's Atacama are large millimeter arrays. The black hole seen in the brightest region on the left of the image, and the structure to the top right is a jet created by the black hole material falling upon. The black hole creates the jet from left to right. The sonification sweeps through the 3-tiered picture with each wavelength mapped to a separate spectrum of auditory tones. Radio waves are assigned to the lowest tones, optical data to the medium tones, and Chandra-detected X-rays to the highest tones. The brightest part of the image coincides with the loudest part of the sonification, where scientists discovered the 6.5 billion solar mass black hole seen by the EHT. Similar generated sounds of the bright loop in a stream of energy flashed from a giant black hole at the center of a humongous galaxy called M87. They were released by NASA as part of an ongoing project to sonify the universe. These sounds can reach up to 53.5 million light years as a succession of orchestral tones. Black Hole Week, an annual NASA social media extravaganza, May 2nd through the 6th, led to some outgrowths like Aaron Carra, an astrophysicist at the Massachusetts Institute of Technology, who led another sonification project to use light echoes from X-ray bursts to map the environment around black holes, much as bats use sound to catch mosquitoes. Black holes, as decreed by Einstein's general theory of relativity, are a gravitational pull that is so intense that nothing, not even light, can escape them once inside a certain region called the event horizon. A black hole can be formed by the death of a massive star. When such a star has exhausted the internal thermonuclear fuels in its core at the end of its life, the core becomes unstable and gravitationally collapses inward upon itself, and the star's outer layers are blown away. The crushing weight of constituent matter falling in from all sides compresses the dying star to a point of zero volume and infinite density called the singularity. Paradoxically, they can also be the brightest things in the universe. Before any sort of matter disappears forever into a black hole, theorists surmise it would be accelerated to near-light speeds by the hole's gravitational field and heated, swirling to millions of degrees. This would spark X-ray flashes, generate interstellar shock waves, and squeeze high-energy jets and particles across space. In one common scenario, a black hole exists in a binary system with a star and steals material from it, which accretes into a dense, bright disk, a visible donut of doom that sporadically produces X-ray outbursts. Analyzing data from a NASA instrument called the Neutron Star Interior Composition Explorer, or NICER, a group led by Jingyi Wang, an MIT graduate student, looked for echoes or reflections of these X-ray blasts. The time detained between the original X-ray blasts and their echoes and distortions caused by their closeness to the weird gravity of black holes offered institution into the advancement of these violent breakouts. As we have now known about NASA's newly released Eerie audio, Hans Zimmer-like sound from a radar that captured sounds from a black hole at the center of the Perseus galaxy cluster. Let's know something more about the Chandra X-ray Observatory, or CXO. It was previously known as the Advanced X-ray Astrophysics Facility, or AXAF. CXO is a flagship-class space telescope inaugurated aboard the Space Shuttle Columbia during STS-93 by NASA on July 23, 1999. Chandra is sensitive to X-ray sources 100 times fainter than any previous X-ray telescope, and this is enabled by the high angular resolution of its mirrors. Earth-based telescopes cannot detect X-rays because Earth's atmosphere absorbs a huge amount of X-rays, which is why space-based telescopes are required to make these observations. Chandra is an Earth satellite in a 64-hour orbit. Subramanian Chandrasekhar was a Nobel Prize-winning Indian-American astrophysicist, and the telescope was named after him. So, this was all about this video. I hope you like the information given in the video. If you have anything on your mind, feel free to comment below. Also, don't forget to like, share, and subscribe to get more videos like this, and also hit the bell icon to get the notification of the latest updates on the channel. And thanks for watching!